Is that it?
Hi and welcome to Extronical. Today we're going to have a look at setting up a temperature probe using a Dallas Semiconductor based chip. If you go to the Extronical website, which I'll just bring up in 1 second. Okay, so look on here, you'll see I've already done the article about it. So if you go to basics, let's just move it up, sorry, so we can see a bit more of what we need to see. 1 second. So basics and Dallas temperature sensing, you'll get the article up there that's been written if you prefer that sort of thing, a more textual approach and with the pictures and everything we're going to go through basically in the video as well. So it's the Dallas DS18B20, but there are a range of Dallas Semiconductor chips which the code that comes with the Arduino or with one of the Arduino libraries will work with. Basically any of the probes you've got from eBay or Banggood or AliExpress tend to have this chip in and will work fine with this example. I'll just shrink that away. Okay, so I'll bring up the actual diagram of the connections, just drag that across, just cover up that. So you can see we've got a temperature probe and both what appears to be both the positive and negative are connected to the ground rail. You can see the ground of the Arduino is connected to this rail here and the positive of the Arduino is connected to this rail here. And for whatever strange reason it might appear at the start, both positive and negative are connected to ground, with the data line connecting to pin 2, D2 of the Arduino, with a 4.7k pull-up resistor connected to the plus 5 volts. That is because this particular temperature probe can actually be used with its own power. So I could connect that red line up to the positive supply, and then it would take virtually no power at all from the Arduino. Or you can use it in what's called parasite mode, which means basically it's going to take what power it needs from this data line as well to power it. And in that scenario, you just connect the red and the black both to ground. It only draws about a milliamp according to the spec sheet, and an Arduino such as this Nano supply about 20 milliamps without blinking. So you could have up to about 20 of these different devices if you so wanted on your pin of your Arduino. We'll go more into what the software is, that this is how this is connected, but for now we'll go on to making the build. So we'll move over to that. Okay, so let's look at wiring up the thermometer. So this is it. You can find these, look on eBay, AliExpress, Banggood, you find these sort of Dallas Semiconductor based thermometers. So inside this little metal cylinder is the actual Dallas Semiconductor chip. Been sealed in, so they are waterproof. They're good to about 100, well I think they're spec'd up to about 125 degrees Celsius, minus 40 or something like that. I've had this up to about 125 degrees Celsius by accident, it wasn't intentional. And it survived, not this particular one actually, sorry, another one I've got, but it survived fine. They do say that prolonged use, it doesn't say how long, but prolonged use of 100 degrees or thereabouts could lead to the leakage into the device and failure. But I've certainly ran my other one, which I've got at 100 degrees or 80, 90, 100 degrees, just over 105 degrees for several sessions, and I've had no problems with it, so they are fairly reliable. So we're going to look at wiring it up. So it comes with 3 wires, with the red being the positive, black being negative, and yellow being the actual signal ground. And as I've already mentioned, they actually only need 2 of these wires to operate. So if I just use another little, sorry, just caught the camera. If I just use a little a bit of a jumper wire just to help point when my big fingers getting in the way. So this is the data and this is ground. If you want, you can actually not connect that to positive volts if you want, but you can actually connect that to ground. So you connect both these to ground, which we will do in a minute, and just connect that to your data line. The device will then actually derive its power from the data line as well. And it's about 1 milliamps, so okay, a typical Arduino might be around 20 milliamps. Some of the other boards might support more. This is around 20 milliamps for this one, so it's well within limits. So I'm just going to connect these two to ground and this one to the data line. So we'll get on with the wiring up. We'll just move that out of the way for now. First thing I'm going to do is I'm going to create a positive rail along here and a negative rail along here. So with the Arduino, I'm going to connect to the positive volts, 5 volts positive, and connect that to our positive rail that we're using. And I'm going to connect the ground to, where's the ground? There it is. To our ground, I'll put it over there, our ground rail that we're going to use. And then we need to bring in the actual thermometer. But what it does need, it needs the, well, we'll connect up, we'll tell you what it is in a minute, we'll connect up the positive and negative. Like I said, the black and the red are both going to go to ground, because, let's push them in, because if we're not using that many devices on our data line, then, so I've connected both them to ground. I'm going to connect the data line just here for now. If we have enough power supply from our particular pin, which we do on the Arduino, we can just parasite some of the current from that pin to supply to actually power our temperature probe. So we've connected that up. We'll bring that back in. We've connected that up, but the data line needs to connect to, so I'll put it there, to pin 2. It can go to any pin, actually. Any pin is fine. When we come to look at the source code, it defaults to using pin 2. So I've just connected to D2 to save time. You could alter the first routine you call to be any of these digital pins and connect to that. But I'm going to use the default, which is digital pin 2, which is what I've connected to. But one of the things you need with this particular temperature probe, with this Dallas chip, the signal wire, so the one where the data is going to go to the Arduino, has to be connected also to plus 5 volts with a resistor of around 5k. Okay, so this is 4.7k, and that's fine. So I'll connect that to the positive rail and to this data line as well. So I'm going to push that in there, push that in there. I think that's made a connection in there. And that is it. It's a really simple connection. So we'll now go back to the software. We'll get the demo code up and running, and the libraries we need, and we'll see how we can go from there. And in a little while we'll also see how we can actually have more than one device on this one wire bus. Okay, so now we've built it, we need to look at the software for it. The software for the Dallas chipset uses something called a one wire bus. And it's literally, if I just bring that connection up again, that diagram up again, it is just one wire that all data is sent over. And it's going to D2, because that's the default for the library we're going to use. But we'll get the libraries first. So into your browser window, so we'll just bring up a browser. Okay, so we're bringing in a browser window, and we'll just we'll just type in 18 B20 and GitHub. Then go to this Miles Burton link, click clone or download, download zip, and get at the bottom. We can get rid of that now, we've downloaded it though. And if you go to sketch, include library, add a zip library, and downloads, and that one, then we should have the library in there, so we can actually then go to file and examples, and oops, go out of the way, Dallas temperature, and I'm going to go for the simple testable. So I'll close that other one down, leaving just that. Okay, and we'll try and upload. I know this is going to go wrong, so I know what's missing, but we'll just try and do an upload for now. And you can see in a second we've got an error compiling, and it is because the one wire library is not included. So we need not only this Dallas temperature file library that we've got just now, we need the one wire library as well, which is basically the protocols for talking over that one wire data bus. So again, if we go back to our web page and just type in one wire GitHub, and this Paul Stroffrigan, I'm probably pronouncing that way wrong, but if you click on that, clone or download, again download zip, which will download in a few seconds. That's done. Move that out of the way. Again into Sketch, include library, add the zip, downloads, and downloads, one wire. That should now be in. So we'll do an upload again. And that's nearly done. Uploading. We'll look at the Arduino. Yeah, that's uploading. And message is going up on my screen. Let's move that out of the way. That's finished uploading. So you may be wondering where the actual results are. We'll see what the temperature is. If you look, it's just using the serial monitor, so it'll print out Dallas Temperature RC control library demo, and it'll go around and look at the devices there. So we'll go to serial monitor. Let's bring that up here. You can see, and it's reading the temperature of 24.75 degrees, 24.81. It's quite a warm day today for where I live. So we'll move that back across, out of the way. So basically all it's doing is, if you look here, we have an object called one wire, and we initialize that with a variable called one wire, so that's going to be of type object one wire, and we pass it a parameter one wire bus, which is basically the pin number. Look up here, we've defined that there, so it's passing the pin number we're going to use for the one wire. And then for the Dallas Semiconductor Dallas temperature object, we're going to call that sensors. It's going to use this object, and it's going to be its way of communicating over the one wire bus with that object there, but we just created the one wire object there. And if you look down really quickly, just start the serial port and print out a little bit, and then we initialize the sensors. And then if you look down here, we request the temperatures, which any and all sensors that are on your bus will respond and give their temperatures, and then they store it into some sort of array, which we don't see. But if we then say get temp by index, so the first temperature sensor it comes across is 0, and that will print out that. So that index 0 will print out that temperature, which is what it was doing. Okay, very quickly, if you wanted to get to read more than one temperature sensor, we'll bring another temperature sensor in. Just this one, and we'll quickly wire that up. So I'm going to very quickly just put the red and the black to ground like the other one. You can see this temperature sensor is a little bit more battle scarred, and we'll connect up the one wire bus. Blue is the data line on this one. As I bought this one a while ago back, and it was different colours for the wires for whatever reason. Using the same thing, we've connected it straight in. No need to add an extra resistor, that one's fine. So we'll look at that very, very quickly. So we need to quickly alter the code. There is a routine to, in fact, if I call it up, I've done some work on multiple temperature sensors, and we'll just open that up and we'll run through the code. Okay, so this is the code. What I'm going to do, I'm going to take it out of there, just select all, move that out of the way, move that out of the way, select all there, just delete that and paste in the code that I worked on earlier for multiple sensors. So this is pretty much the same. I've got a variable that says how many sensors there are, the number of sensors currently sets to 0 when it's initialized, and then there's this routine you can call get device count. So that goes through the one wired bus and counts the number of devices on there. All devices on a one wired bus have a unique ID. They have a 64-bit, I think it's 64-bit, yeah, 64-bit ID number they can have. So they manufacture these, and every single one for the one wire bus has a unique ID for it. So we get how many devices are on our one wire bus and we store it in there. and then I quickly just print out how many sensors we've found. So I print sensor, and then just make it a little bit more pretty by just checking whether it needs to have a plural S on or not. Excuse me. So it says so many sensors available, and then we loop round again. So request temperatures, when it's got all the request temperatures back in, it says done, and then I go through how many sensors I have, and basically then just print out the result for each sensor. So we'll compile and upload that one. Okay, that's nearly done. Should stop uploading soon. That message has come up again. Not sure why that keeps doing that at that point. And it's finished uploading, so we should have two temperatures. Go and check the serial monitor. So serial monitor, bring that back over here. Let's have a quick look. I'll just stop the auto scroll for a second so we can read the top. So yeah, two sensors are available, so it's found both sensors. And initially it's found that probe 0 is 24.69 and probe 1 24.75. You can see they are calibrated, I think, extremely well at the factory. That is really quite close to each other. So we'll just put the auto scroll back on. We can see the later results as they come in. Because what I'll do, I'll switch to the other camera as well, so you can see the probes, and we'll actually alter the temperature probe of what we maybe probe 0. So we'll hold on to that with my hand and warm it up, and we should see one of them going up in temperature. And in fact it's probe 1 that's rising in temperature. It's now up to 26, 27. Just keep my hand right on that, and that should rise up to around about 34, 35, maybe 34 degrees skin temperature, something like that. And the other one is remaining the same, so we'll just leave that there and we'll swap to the one that should do the same. So we'll raise the temperature of the other one up. Yep, 25, 25.31, 25.5, 25.69, and it's rising again. Yeah, 27, let's get up to 28, etc. So both are being independently read from. So if you need multiple sensors, you could even add a third sensor, a fourth sensor. In fact, if you didn't want to use its own power bush, you could add up to probably 20 sensors to this Nano. But if you want to use its own, if you want to connect it to the power rail, then you can have many sensors connected. They only use it about a milliamp. I can't think what application might need that many temperature sensors, but you can add other one-wire sensors as well, for whatever project you're working on. But that's it for now. So like and subscribe, and I'll see you next time. Bye.